Alright, so today I'll be going over Leetcode 238, product of an array except for self. Given an integer array, nums, return an array answer such that answer at I is equal to the product of all elements of nums except nums at I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operation. So for the first example, we're given this array, and then we're given this output array, which is, as the name suggests, just the product of each and every other element, and the same thing here. And so two important things to note about this problem is that you need to make sure that you're fitting in this 32-bit integer, like any numbers that you create during your code, you don't want it to be greater than 2 to the 32 power. And then another thing to note is that this should be an O of n times, so you want to make sure that your solution runs without any nested for loops, which would create order n squared or anything greater. Alright, and another thing to note is that I got this solution from a YouTube video, so I'm just explaining it to the best of my abilities. It was written in a different language, but I just transported it to Python, and then I'm just trying to explain it. So yeah. So now the biggest thing to understand with this is that what we're going to do is we're going to create two different arrays. We're going to create, so I kind of just wrote the our input here. So we're going to create a left array and we're going to create a right array. And the reason why we want to do that is because we know that the product of any number except for self, it's really just the product of anything that came before it and the product of anything that came after it. So what we're going to do is that we're going to create an array that basically holds that for each number. So the left array, for example, will hold the product of any number that's left of its of the corresponding index in the nums array. So if we were to fill this array out using our code, and let me walk through the code real quick. So first I create a left array. Then I initialize the left array at 0 to be 1, since we know that we have nothing to the left of our first index. Then we create a right array, and for the same reasoning, we make sure that the rightmost index is made 1, and then I created my answer array. Now I loop through the array, and then I say that left at I, and make sure that I starts at 1, so we're not starting at the first. So we say that left at I is equal to nums at I minus 1 multiplied by left at I minus 1. And then we say the same thing, and we start from not the rightmost index, but the one to the left of it, that right at I is equal to nums at I plus 1 multiplied by right at I plus 1. And after that, we create our answer array, which is just multiplying both of the indexes together of the left and the right. And it'll make more sense once I actually go through and kind of explain it. So walking through the code, we know that first we're going to start with 1 right here. Then what we do is that we say that left at I, so now our I is going to be 1 because now we're starting this loop. So left at I is equal to nums at I minus 1, so 1 multiplied by left at I minus 1, which is also 1, so we're going to get 1. Then our I increases, and we say, okay, the same thing, we're going to take the one before it and multiply it by the one before it. So we're going to get 2, and then boom, for 4, we're going to get the one before it, and we're going to get the one before it, and we're going to get 6. And what I want you to note is that if you look at it, if you start at 2 and then you go and you look straight down, you can see that what comes before it is 1, which, as you can see, since there's only one number there, it's just going to stay as 1. We can see the same thing for 3. If you look at its corresponding left index, we have 2, which, as you can see, 2 multiplied by 1 is 2. And the same thing for 4. If you look straight down, you can see that we had 3 multiplied by 2. So for the right array, we already know that our leftmost element is to become 1. And after that, what we want to do is we want to take 4 multiplied by 1 to give us 4. And I'm going to fix the spacing as we come along. It's going to be a little messed up because some of the numbers are going to be greater than bigger than 10. So it's not going to really fit well. But then we're going to take, for our next one, we're going to end up doing 3 multiplied by 4, which gets you 12. And then we can continue along, and we say, okay, now take, for this guy, we're going to take 2 multiplied by 12, gets you 24. And that will give you your 4 elements needed for this right array. So I want you to note again, if we take a look at For example, the number 1, we multiply all the numbers before it, we get 2 times 3, which is 6, 6 times 4, which is 24. Then we start with the number 2, multiply all the elements that came before, 3 times 4 gets you 12. You get your number 3, everything that came before it, we get you just 4, and 4, because there's nothing before it, we just in place a 1. And so after that, all you do is, because now you can see that for each number we have its both prefix and its suffix. So if we just multiply these two numbers together, we should get the array of numbers that we need. And that's basically what we do. So again, like I said, since I got the solution from a YouTube video, I'll be putting that in the description. And yeah, I hope this made sense.